Hi everyone, welcome back to Dr. Carminati's YouTube channel. Today, we're talking about something that will change the way you think about artificial intelligence and its ability to understand language and concepts. We're exploring what's known as the geometry of concepts in large language models and how these advanced AI systems organize knowledge in ways that resemble human thought. This video is all about uncovering the structures within AI that make it possible for these systems to understand and categorize complex ideas. If you're new here, or if you enjoy deep dives into how AI really works, don't forget to like, subscribe, and share your thoughts in the comments below. Let's get into it. Now, when we think about artificial intelligence, huge language models like the ones used in tools like ChatGPT or search engines, we usually think of them as just really smart text generators. But these models are far more complex than they might appear. Inside each model, some intricate layers and structures allow them to make sense of language, concepts, and the relationships between ideas. One of the keys to this complex understanding is something called a sparse autoencoder. Let's break that down. An autoencoder is a type of neural network that's designed to take information, process it, and then try to reconstruct it as accurately as possible. In doing so, the autoencoder learns to identify essential features of the data. Essentially, it knows what's truly essential and what can be ignored. Sparse autoencoders go a step further by focusing only on the most crucial aspects of each piece of information, representing concepts in a compact, highly efficient way. This is particularly important because when it comes to language and knowledge, there's much information that can be stripped away to reveal the essence of a concept. Now, here's where things get really interesting. In recent research, scientists have found that within these language models, the concepts and ideas are organized in what can be described as a geometric structure with 3 distinct levels. Each of these levels has a different way of arranging information, and each plays a unique role in how AI understands the world. These levels are the atomic level, the brain level, and the galaxy level. At the most basic level, which is called the atomic level, concepts are broken down into very small, highly structured forms. You can think of this as the building blocks of language and ideas. Just like in chemistry, where atoms combine to form molecules, these atomic units of knowledge combine to form more complex ideas. For example, a language model might understand the words man and woman individually. However, it also understands the relationships between them, such as their connection to terms like king and queen. What's amazing is that this structure often takes on geometric shapes, such as parallelograms, that help the AI model represent relationships between words. This geometric representation lets the model understand not just words themselves, but also how words relate to each other in meaningful ways. Moving up, we reach the brain level, where concepts are grouped into clusters or modules that resemble functional areas in the human brain. Imagine that all concepts related to math, science, or language have their dedicated regions within the model, just as the brain has areas specialized for specific tasks. This modular organization means that the model can manage complex fields of knowledge without letting them overlap unnecessarily. For example, the knowledge the model has about chemistry doesn't interfere with its understanding of literature, just as the areas of our brains dedicated to different skills work independently but harmoniously. This is an important aspect of how AI systems manage knowledge in a way that is efficient and surprisingly similar to our cognitive structures. Finally, we have the galaxy level, which is the most comprehensive structure within these models. At this level, concepts don't just sit next to each other in isolated clusters. They form large networks that are densely interconnected. Researchers have found that this large-scale organization resembles what's known as a power law distribution, meaning that certain concepts are extremely well connected while others are more loosely associated. In practical terms, this arrangement allows AI models to not only understand individual ideas, but also to recognize broader patterns and connections between fields. So the model can go from understanding a specific concept like quantum computing to seeing its relevance within physics, mathematics, and even AI, making it easier to draw connections across discipline. So why is all of this important? Understanding the geometry of concepts in AI models has huge implications for both the development of artificial intelligence and our understanding of human cognition. First, by knowing how to structure knowledge within AI, we can make these models more accurate, efficient, and helpful in real-world applications. Imagine having an AI assistant that can not only understand specific questions, but also draw connections across fields of knowledge, making it a valuable tool for interdisciplinary work, whether in science, technology, medicine, or other areas. Furthermore, this research brings us closer to understanding how our own minds might be organizing information. The parallels between the AI structures at the atomic, brain, and galaxy levels and our cognitive architecture suggest that we're not just building machines to work like tools. We're building machines that might one day understand knowledge in ways that reflect how we think. This could change everything from how we teach and learn to how we create technology that collaborates with us on complex problems. This understanding also allows us to target specific issues within AI, like bias and interpretability. For instance, by mapping out the brain-level modules, researchers could more easily identify areas where the model might be making unfair assumptions or misinterpretations based on the clustering of concepts. In other words, by visualizing and understanding these structures, we can develop AI that not only works better, but works more ethically and transparently. So there you have it. By exploring the geometry of concepts in large language models, we get a peek into a future where AI can handle knowledge in ways that closely mirror human thought. This isn't just a technical achievement, it's a conceptual breakthrough that could redefine what we think of as intelligence, both in machines and ourselves. As AI models continue to evolve, understanding how they structure and interpret knowledge will be crucial for building technology that is more aligned with human values and more capable of solving complex, real-world challenges. Thank you so much for watching. I hope this video gave you a deeper appreciation for the complexity and potential of AI in organizing and understanding knowledge. If you enjoyed the video, please hit that like button, and don't forget to subscribe for more insights into AI, technology, and how they shape our world. Share your thoughts in the comments. Do you think AI will ever truly understand concepts like we do? I'd love to hear what you think.